So hey guys, welcome again to my vlog. So for today we discuss the chapter 7 tutorial entitled transport layer. So let's proceed. The primary responsibilities of transport layer protocols have three. The first is tracking the individual communication between applications on the source and the destination host. Second is the segmenting data for manageability and reassembling segmented data into streams for the application and at the destinations. So, identifying the proper application for each communication stream. So, next is the application communicates with one or more and remote host. It is the responsibility of the transport layer to maintain and track these multiple conversations. Transport layer protocol have services that segment the application data into blocks of data that are an appropriate size. A header used for reassembly is added to each block of data. This header is used to track the data stream. The transport layer assigns each application an identifier. This identifier is called a port number. Each activity is a software process that needs to access the network is assigned a port number unique in that host. So a directed broadcast is a message sent to all hosts on a specific network. It is useful for sending a broadcast to all hosts on non-local network. A multicast message is a message sent to a selected group of hosts that are part of subscribing multicast group. A limited broadcast is used for a communication that is limited to the host on the local network. A unicast message is a message sent from one host to another. So with the IPv4 address, a subnet mask is also necessary. A subnet mask is a special type of IPv4 address that coupled with the IP address determines that the network subnet of which the device is a member. So let's proceed. An IPv4 address is divided into two parts. So the two parts are the network portion and the host portion. The network portion is to identify the specific network on which a host resides. So the next is host portion. Host portion is to identify a specific host on a network. A subnet mask is used to identify the length of each portion. So, broadcast messages consist of a single packet that are sent to all hosts on a network segment. This type of message are used to request IPv4 addresses and the map upper layer addresses to lower layer address. A multicast transmission is a single packet sent to a group of hosts and is used by routing protocols such as OSPF and RIPv2 to exchange routes. The address range 224.0.0.0 to 224.0.0.255 is reserved for linked local addresses to reach the multicast groups on a local network. There are three techniques to allow IPv4 and IPv6 to coexist on a network. Dual stack allow IPv4 and IPv6 to coexist on the same network segment. Dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. Tunneling is a method of transporting an IPv6 packet over an IPv4 network. The IPv6 packet is encapsulated inside the IPv4 packet similar the other types of data. Networking address translation 64 or NAT64 allows IPv6 enabled device to communicate with IPv4 enabled devices using a translation techniques similar to NAT for IPv4. So next is multicast, anycast, and unicast are types of the IPv6 address. There is no broadcast address in IPv6. Loopback and linked local are specific types of unicast addresses. There are three elements that make up the IPv6 global unicast address: a global prefix which is provided by an ISP, a subnet ID which is determined by the organization, and the interface ID which uniquely identifies the interface of a host. A ping command feedback on the time between when the echo request was sent to a remote host and when the echo reply was received. This can be a measure of the network performance. A successful ping also indicates that the destination hosts are reachable through the network. The purpose of ICMP messages is to provide feedback about issues that are related to the processing of IP packets. So, this is the first scenario. An administrator wants to configure hosts to automatically assign IPv6 addresses to themselves by the use of the router advertisement messages, but also to obtain the DNS server also address from a DHCPv6 server, which address as assignment method should be configured. Stateless DHCPv6 allows clients to use ICMP v6 router advertisement or the RA message to automatically assign IPv4 addresses to themselves, but then allows these clients to contact a DHCPv6 server to obtain additional information such as the domain name and the address of the DNS server. SLAAC does not allow the client to obtain additional information through DHCPv6, and stateful DHCPv6 require that the clients receive its interface address directly from a DHCPv6 server. RA messages, when combined with the EUI64 interface identifier, are used to automatically create an interface IPv6 address and are part of both SLAAC and stateless DHCPv6. So, next is a user is executing a trace cert to a remote device. At what point would a router, which is the path of the destination device, stop forwarding the packet? When a router receives a traceroute packet, the value in the TTL field is decremented by 1. When the value in the field reaches 0, the receiving router will not forward the packet and will send an the ICMP time exceeded message back to the source. So the next scenario is, which network migration technique encapsulate IPv6 packet inside the IPv4 packet to carry them over IPv4 network infrastructures? So the answer and the explanation is the tunneling migration technique encapsulate an IPv6 packet inside the IPv4 packet. So because encapsulation assemble a message and adds information to each layer in order to transmit the data over the network. Translation is a migration technique that allows IPv6 enabled devices to communicate with IPv4 enabled devices using a translation technique similar to NAT for IPv4. The dual stack migration techniques allow IPv4 and IPv6 protocol stack to coexist on the same network simultaneously. So next is an IPv6 enabled device send a data packet with the destination address of FF02 column 1 dot. What is the target of this packet? So the explanation is, this address is the one of the assigned IPv6 multicast addresses. Packets addresses to FF021 are for all IPv6 enabled device on the link or network. FF02, so for all IPv6 router This address is the one of the assign of the multicast address. Packets addressed to FF0201 are full or IPv6 enabled on the link or network. So that's all for the chapter 7. So I hope you learned something from my blog. So again, I'm Brian J. Asi and this is my channel. Thank you for watching and listening. So